Okay, so now we're going to look at part 2. So the setup for part 2 is two 150 gram masses, which is 1 and 2, 131 degrees apart. And there is a third mass hung at the angle bisector, which is at 245.5. And we want to find the mass that equals the resultant vector between these two masses, and so sets the total vector addition to 0. To do that, what we're going to do is simply add masses to the 50 grams that's already hanging there until, like we saw in the intro, the ring hovers over the center. As now you can see that it's pulled more by these two and is pulled against the peg in that direction. So we're going to add masses to this one until it sits nicely over the center. So if we add 50 grams, it's not quite enough. 50 more grams is too much. So we're going to take off that 50 grams. And we're going to go smaller. We're going to go down to 20 grams. So not too much, but it is starting to get towards the center, so we're getting there. And then 20 grams again is too much. As you can see, it pulls all the way against the peg. So we're going to go down to 10 grams. There's a little too much. You can see it's drifted past the circle. And so let's go down to 5 grams. And that situates pretty well over the ring. And so as you can see, and maybe I can zoom in a little bit, you can see that it hovers right over the ring and that it is indeed balanced. So let's zoom in a little bit. And you can see that that ring pretty much covers up that white circle and that target in the middle. And so from that you can tell that we found the correct mass for it to be balanced. And now what you're going to do is figure out what that mass should be mathematically, and you can compare the two to see how close you were.